Alright, here we go. Now we're going to jump into the cooking loss test, very similar to the butcher test. Now we're going to jump into cooking loss test. Alright, and we're going to follow the same procedures that we did last time. So right here you can see I've already put in the 135 pounds, which is what we're dealing with here. Okay, 15 legs are used to make the calculation. That's to let you know there's on average 15 legs in that weight. 7-ounce portion for down here at the usable meat. So we'll go ahead and get that in. That's going to follow the same procedure. So we have this. And now what we'll do is we'll start working our way through. Whenever you start a cooking loss test, this is exactly how you want to go ahead and present it at the very beginning, because they're all the same. OW is the original weight, and what we're going to do is we know our original weight is 135 pounds. Okay, that's given to us in the example. So here we have 135 pounds. Our ratio to total weight, the 135 divided by our original purchase weight, 135, so we get the 100. The value per pound equals the $2.10 for a total value, 135 times the 210 of 283.50. Okay, and once we get here, we actually follow the same procedure as we did earlier. And actually, I'm going to go ahead and make this. So now we have that whole portion in. Now what we're dealing with is, after that is trim weight. And the thing that we're dealing with right here is we are dealing with an oven-ready product, because you don't find trim weight listed in any of the details. So our trim weight is going to equal 135 pounds. The ratio to total weight is going to be 100%. We don't put in a value per pound, but our total value is going to equal the 283.50. It's the same thing, because we bought a product that's ready to go into the oven as soon as we get it. Now our LIT, or our loss in trimming, it's going to equal our original weight minus our trim weight. We find that we didn't lose anything. We didn't lose any percentage of anything. We do not do anything related to the value per pound, but for our total value, we've lost nothing. Now for both of these right here, these items are not used. Okay. Now we're going to look and move into our cooked weight. So we have this taken care of. These 15 legs come in later. Okay, now our cooked weight, we are given that's 120 pounds. And we find our ratio to total weight is 88.89%. So what this means is that we took 135 pounds and put it in the oven, and when we pulled it out after it was cooked, it shrunk up to 120 pounds. Okay, we don't put anything in the value per pound, and our cooked weight is still going to be the 283.50, because it is that original item we put in. We're taking out that whole thing, and what we're trying to do is maximize the value or the cost that we're actually going to pass on to the customer. Okay, so once we do that, again, we're not using any of these items. Now here, what we would do is we need to figure out our loss in cooking. So this is our trim weight minus our cooked weight, and we lost about 15 pounds. The value per pound we do not adjust, and the loss in cooking, what we do again, we take our trim weight minus the value of our cook weight, and it's a 0. Then we go ahead and just run that across. Now the next thing we look for are bones and trim that are listed. Now if you'll notice, bones and trim are not listed here, but if you see, we have a saleable weight of 75 pounds. So what we need to do here is, this is 75 pounds. So to figure out our bones and trim, we need to find we would take our cook weight minus our bones and trim. So it would be our cook weight minus bones and trim gives us this. So in order to find this, we need to go ahead and take our cook weight minus our saleable or our usable item, and that lets us know that after we pulled it out of the oven and carved it up, we lost about 45 pounds in meat and other byproducts. We put no value on our bones and trim. Again, trying to maximize the cost that we're going to pass on to the customer. So we go ahead and run these through. And now what we're dealing with down here is just going to be our usable product. So the first thing that we deal with is we are going to find our ratio to total weight. Now this ratio to total weight number is also referred to as a yield percentage. Means, in other words, after we got this item and we cooked it down, it yielded 55.56%. Okay, our total value is still going to be $283.50. And again, the reason that this is done is we bought a product at 135 pounds for $283.50. Now we're down to 75 pounds, but still $283.50. Now, as we move through, we do the exact same things here as we did in our butcher test. Cost of a usable pound is $3.78. We take our cost of a usable pound divided by 16, gives us 24 cents per ounce. Then we take our ounce portion size, multiply by the cost per ounce, get $1.65. To get our cost factor per pound, cost of a usable pound divided by our original purchase price. Then we get our portion cost divided by our original purchase price. And we have our index set up. So now that we've done that, and I kind of moved through it quick because that's the exact same procedure that you follow when you do the butcher test. So we've kind of run through that and taken care of that. Now we're going to still use a 7-ounce portion, but if you notice, our dealer price has changed. So our new dealer price that we're dealing with, I'm going to put it right here. One is at $2.25, is at $2.49, and one is at $1.89. So to show what our new portion costs are going to be, we're going to take our 7-ounce portion, which is the same one, multiply it by the new dealer price, and there we have it. Oops, wait. Oops. Let's see. Equals new dealer price times cost factor per portion. Turn that into the dollars. Cost factor per portion times the new dealer price. Cost factor per portion times the new dealer price. So here we've done it 3 different times, 3 different dealer prices, but our portion size is the same, and it shows how we would adjust that to take care of these 3. Now just again for some more practice, what we have here, we have new portion size, new dealer price. So what we have is, for the first one, we have a new portion size of 6 ounces. So what we're going to do is we're going to convert that into pounds. 6 divided by 16. And for the second one, we have a 5 ounce divided by the 16. So here we have our 2 new sizes. And for the first one, what we're going to do is we're going to take our new portion size, multiply by the cost factor per pound, and multiply that by our new dealer price, which is $2.19. In case you're wondering where I got the $2.19 from, that's over here. Okay. Then we're going to do it again here. So we're going to take our new portion size, multiply it by cost factor per pound, and multiply that by our new dealer price of $2.29. And here is how we would make the adjustments based on portion size and dealer price. And if this helps you, this one will be at $2.19 and this one will be at $2.29. Okay, just to show those adjustments and how we would use this information to quickly navigate figuring out these new costs. Okay, and that takes care of this part right here. Now the price increases to $2.25 per pound. The manager wants a new portion cost to be $1.65. What portion size is needed? So what we're going to be dealing with is the formula of our portion cost is a dealer price times the cost factor per pound times the new portion size. So what we need to do is manipulate the formula so we can figure things out. So what we're dealing with here is $2.25 per pound is the new dealer price. We want $1.65 to be the portion cost. Now I don't know if you remember how we used the formula up here, but then now what we need to do is manipulate the formula so we know what we're dealing with. So the first thing that piece of information that we do know is that we do know the new portion cost is going to be $1.65. So we want to go ahead and set up the formula, $1.65, okay, and that's going to be divided by the new dealer price, which is $2.25, and then we're going to multiply that $2.25 by our cost factor per pound. And this lets us know that our new portion size is going to be 0.407 pounds. So this equals 16 times that. So that lets us know we're dealing with about a 6.5 ounce portion size. And the reason I'm going through this and showing you is when you know and understand the formula and how to use the cost factors, this is what a lot of establishments do to work their prices up and down, adjust their portion size. It's something that they do just to help not have to constantly recalculate things. Okay, so we've taken care of that. Now one of the things that we're looking at here is, for the next one, how many average size legs of lamb are needed to be purchased to serve 6-ounce portions to 270 people. Well, the first thing that we would need to do here is we need to figure out an average size of the leg. So this is going to equal our 135 pounds divided by the 15 legs. Okay. I'm going to do my best to get back on track. Let's see. Okay, what we have here for the next one is we have 270 people, and we're trying to serve 6-ounce portions of product. So we need to figure out how many average size legs need to be purchased in order to do that. So the first step is we figure out how many people, 270, and the portion size. And this is going to tell us our edible portion amount. So we need 101.25 pounds of product. Now, one of the things that we also need to know here is our yield percentage. And we know our yield percentage is roughly 55-56%. So we take that. Actually, let me back that up. We need to take our edible portion amount divided by our yield percentage, and that lets us know that we need roughly 182 pounds of product. We know that our legs weigh about 9 pounds each because we take the 135 and divide it by the 15 legs. Okay, so to figure out how many legs we need to purchase, we need to take the 182.25 divided by the 9. So we need roughly 20.25 legs, and we need to purchase 21 legs in order to serve 270 people a 6-ounce portion of product. Now, again, the reason I'm going through all of this is to show you how this information is extracted and used by restaurant managers to prepare food service for a special event or anything like that. So there's a lot of different applications that come into play. Now if we look at the next one, we know that last month we used 82 legs of lamb. How many standard 7-ounce portions should have been produced from 82 legs? So what we need to do is we are dealing with the 82 legs, and we are dealing with 9 pounds roughly for each leg. So we take the 82, multiply that by the 9 pounds, so we know we had 738 pounds of product. Okay, of that 738 pounds of product, we know only about 55-56% of it was usable. So what we need to do is take that 738 pounds of as purchased product, multiply it by our yield percentage, and we're dealing with roughly 410 pounds of edible portion. We know we're dealing with a 7-ounce portion, so we need to take that 7 divided by 16, and that's roughly 0.4375 pounds. So we take the 410, divide that by our weight. So we distributed roughly 937 portions of legs of lamb last year based on that information. So again, that's another kind of component of how this is used by restaurant managers to determine information from one month to the next. So now what we're going to do is we're going to kind of look, if the standard portion was 6 ounces, how many portions could have been sold. So basically we're looking at this same piece of information of the 738. If you look right here, the 738 still with the 55-56% as far as the yield percentage. Now the only difference is right here we're dealing with a 6-ounce portion. So 6 divided by 16. And if we had been dealing with a 6-ounce portion last year, we could have actually produced 1,093 servings last year, increasing revenue, decreasing our potentially our costs per unit. So these are different things that that managers look at as far as playing with and adjusting and those kinds of things. Now here in this last part, just looking at trying to figure out what we're going to do in the future, and one of the things that we want to look at is what size would work best if we only have 30 legs of lamb on hand for today and we're trying to serve 350 people. Now the first thing that we're dealing with, we have 30 legs. We also know that each leg weighs about 9 pounds. So what we want to do is we want to take those 30 legs, multiply it by the 9 pounds, and we end up with about 270 pounds of product. We also know that this 275 pounds of product is only going to give us about 55-56% of usable product. So we have our 150 pounds of usable product. Now what we need to do is we need to take that and we divide that by 350 people. So this equals our 150 divided by our 350 people. So roughly that is 0.4285714. You know, there's 16 ounces in a pound, so we take that, multiply it by 16. We're dealing with 6.85. Now, one of the things that we want to do in order to be safe when we're actually portioning it out, instead of taking it to 6.85, we can serve anywhere between a 6 and a 6.5 ounce portion to that group of people and still make sure that we have plenty of product to go around. This will also help account where if somebody drops something that we may have enough to recreate it. So this second example shows how you do a cooking loss test and how this information can be used for basically the food and beverage portion of planning an event.